back to page 280 from yesterday on your student journal. You were supposed to do problems 4 and then, or problem 4 on page 280. On 281 we had 10, 11, 12. Okay, I can't get these pages. There we go. So 10, 11, 12. So I want you to compare your answers with your groupies for 4, 10, 11, 12 right now. Okay? Number 4. I'm going to put up the work for number 4. And then we can go through questions on it. There are many different ways to do this, but I first changed number 4 to degrees. Okay? I've made cosine of 525, which is what 35 pi over 12 is. And coterminals with that would be cosine 165, just to make it a little easier on myself. Okay, so 525 is 360 plus another 165. So I just got rid of that 360 and said, okay, I'm at 165. And 165 is 135 plus 30. Now there are other ways to do that, but that's the route I went. Okay, from there, I know that 135 and 30, I actually wrote it in radians. If we want to use that, you don't necessarily have to. But cosine of 135 is negative root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 135 is root 2 over 2. And sine of 30 is 1/2. So this gives me negative root 6 over 4. And root 2 over 4, which is negative root 2 minus root 6 all over 4. Okay. Now how many got that answer? Okay. What are some different what are some different strategies? Actually, before we do that, what are questions on this? Okay, so what are some strategies you use then? Yeah.
We did 480 and 45 degrees.
480 and 45? Okay. So 480 plus 45. 480 is 360 plus 120, right? So, all right. And so you could say that you're looking at a 120 degree angle there if you want to think of coterminal. Okay, so 120 and 45, so that would be cos 120, which is, I can't I write cosine? Cos of 120, which is negative 1/2. Okay. And cos of 45, which is root 2 over 2. And sine of 120, which is root 3 over 2. And sine of 1/2, which is root 2 over 2. Did you get the same answer?
We did, but we just messed up in the work part.
Okay, so you figured out what you did wrong? Okay. So it gives us the same here. Yep. Okay, others? Okay. Let's take a look at the next problems there. Problem 9, 10, 11, and 12. Number 10, what'd you guys get? Tan X. Sounds like a as seen on TV product or something. Okay, it is tan X, yes. There is the work for it. Okay, these are a little more straightforward in terms of work. Okay, tan X. Questions on the work. If you're rushing to get it down, it'll be hung up later. But okay. Yeah, Matt? Right here? It's tan X. Well, you're... do I not have my paper? I've already been. I don't need the one out. So you're going from, so we're doing A minus B, right? Yeah. and you're looking at this and going, why can't I? There we go. The question he's asking, since we're here, a minus b, he's saying, why do I have a plus right there? Is that what you're asking? Okay. So the answer would be, yeah, it should be a minus right there. Yeah. It's unbelievable. Having all kinds of technical errors here. Yeah, it should be a minus there. Okay, but as you process this and go your tan x plus sine 2 pi and cosine 2 pi, this part ends up canceling to 0, right? Yes, this should be a plus here. Yeah, so that's just me. That's me making a mistake on the adding, but it doesn't change the result of the problem, right? Because right here, this, which is minus, and that's plus, but this part becomes 0, and this piece becomes 0. So it ends up giving us the tan x. Okay, but yes, good question. I need to find a new pencil. My new pencil is now a pen. All right. Yeah. Yeah, unfortunately, it's not erasable.
You should get one of those friction pens that have erasable stuff.
Well, it's because the 0.
No, I understand why, but it's just weird.
All right. Hey, tell your neighbor what you got on number 11. Thank you, Matt, for pointing that out. Number 11. Okay, what do we get? Cosine x. There it is. I'm going to try the pencil again. I think something's wrong with that. Let I just break that piece. Okay? Questions on it? All right, what'd you get on the next one?
I got sine x.
Negative sine x. Yes, negative sine x. I'm positive that it's negative. Yeah? Okay? All right. Any questions? Okay. Hey, we are going to move on to problems 5, 6, 7, 8, and 13, 14. We're not going to solve every single one of those, but let's go to number 5 real quick. Number 5, evaluate the expression given that sine A is negative 4/5 with pi is less than A, which is less than 3 pi over 2, and cos B is 5/13 with B being greater than 0 and less than pi over 2. So, based on the information they gave you, what does all of that stuff mean? Talk with your group real quick. You should know what all that means, I hope.
It would be in the third.
Okay. Hey, so let's start with first sine A. They're telling us that sine A is in which quadrant? This says it's between 3 pi and pi, or 3 pi over 2 and pi, which is down here. Okay? So the negative is actually coming from which portion of the ratio? Sine is what over what? Opposite over hypotenuse. So my triangle that I'm dealing with is right here, right? Okay? Yes, it is a 3, 4, 5 triangle. Okay, so based upon the information they gave us with sine A is equal to negative 4/5. This is opposite. That's hypotenuse. opposite of theta, hypotenuse, is 5. This is 4. We're actually getting the negative portion from this piece right here because that's the negative portion of sine. We're down here in the negative y values. Okay? So the reason we'd have the triangle is to figure out that side length, which is 3. The reason we need to figure that out is because to calculate this, we have to use the difference formula for cosine. So cos A cos B plus sine A sine B. Okay. It does say cob, that's one. Or cob. Or I don't know what it says, but it's supposed to be cos. Okay? So we've got that. We know sine A. We actually need to know cos A as well. This is angle A. Okay, so the cosine of A is -3 over 5. Yeah, because it's negative x values as well over here. This is a negative quadrant. It's a very pessimistic quadrant over there. Okay? -3/5. Okay, so cos A, -3/5. Cos B, we don't know yet. We will. Actually, we do know. It's right here, but we're not going to deal with it yet. Sine A, -4/5. And sine B, we don't know yet, but we will. All right, so let's figure out cos B and sine B. You guys figure it out. You can do that.
That's another special triangle.
Yeah, we're in quadrant 1, right?
Yeah.
And it is another special triangle. This special triangle is a adjacent 5, hypotenuse 5, 12, 13. Yeah, if you know those special right triangles, that helps out. So sine of B, that's cos of B. Keep forgetting letters here. Sine of B is equal to 12/13. So cos B, 5/13. Sine B, 12/13. And now we're just doing the math. Putting fractions together. Deal with this term. -15. Actually, let's reduce. Save some time there. -3/13. Plus, can't reduce here, that's sad. -36. Just joking. -48. That wasn't one of my better jokes. Over 65. Walsh, you want to say something there? No? Okay. All right. When I'm putting those two things together, you don't just get to crank them on your calculator and round. Right? You guys over there, how you doing? Yeah? Okay. Just making sure. All right. 13 and 65 both go into 65. 13 goes into 65 how many times? Yes, 5. Good job. 5. And that would be 3 times 5, which is 15. -15 65ths and -48 65ths is -63 65ths. That is our solution. Okay, so a little work on that. However, I know you can do it. Yeah, I have confidence in you, man. Okay? Questions there? All right. By the way, if you did this one, what makes this one easy is you already know the values for A and B. You just have to change the formula. You know sine A, cos B, sine B, And when you're dealing with the sine here, remember you're still using sine A, sine B, and cos A, cos B. So you're using the same pieces on that one that you were using over here, so you don't have to recalculate everything. All right, I want you to turn the page. Take a look at problem number 7. All right, we are going to go ahead and try number 7 there. Keep this page handy because you're going to use those values. Or maybe just have the triangles ready for you, right? You're going to use at least the side link, or yeah, you're still doing. Actually, I'm just going to redraw the triangles over here. You're still using these triangles. So it's important to know your formula there. I always mess up on the tan formula. I don't know if I said that yesterday in class. These are the ones that some reason I have. Well, obviously, like on the answer key, I have the wrong formula. I had the pluses and minuses messed up. Yeah, that happened. Not to me, Dana. Maybe from a different part of the country. So we need to know tan B, obviously, and we need to also know tan A. So we use our opposite over adjacent. So 4 over 3. Just plug in our different pieces in. So it's supposed to be A there. So tan A is 4/3. Tan B, 12/5. When we're adding here, we've got to find a common denominator. That common denominator would be 15. So if this is 15, 3 times 5 is 15. So 4 times 5 is 20. This is 15. 5 times 3, so 12 times 3, 36. Getting kind of squished up there, hard to see. So fix that up. So we have 20 fifteenths and 36 fifteenths, which when we add together we get 56 fifteenths as our numerator. All over, we have 1 minus, cross cancel, 16/5. Now, for those of you that are like, I just do fractions on my calculator, this is where that's a little tougher. Definitely need to know how to work with the fractions. They get kind of ugly here.
Is that a 5 or a 3?
This is a 5. Can't you tell?
Nope.
Okay. That's probably why you asked. All right. Okay, what is 1 in terms of fifths? It's 5/5. So 5/5 minus 16/5 is negative 11/5. And 56 over 15. We don't divide, right? We multiply by a reciprocal. So 56 fifteenths times 5/11ths of the negative style. Okay, so remember to put parentheses, otherwise you may think you're subtracting there. Cross cancel. 5 goes into that 3 times, into that once. You get 56 over negative 33, or negative 56/33. Are the best? Yeah, I agree. They are the
It's
best.
just like you do so much work and then you get this answer like 56, negative 56/33. I feel like there should be like an X in it, you know?
You could throw an X in there and just be wrong. All right. Oh, okay. Okay. I'm glad you laughed. All right. Hey, questions on it? It's really just plugging in the pieces, chugging out that answer. Plug and chug. All right. Number 13. We got 2 more problems, guys. We have to do 13 and 14. Then we're done. Then our final lesson is over. It saddens me. It's the last lesson of the year. This is a fun, what are you talking? Every lesson has been fun.
It's a fun lesson. End of the year. Because it's at the end of the year.
It saddens me. Fun lesson.
I said,
Guess what? You'll get to teach it again next year.
Oh, okay. All right, a lot of good ideas up here. However, hey, here we go.
I think something makes a good point.
This is A and B. We are now solving the equation. Now, listen, when we're solving, that means we are coming up with a value for what? For x. We're solving for x. We want to know what x equals when we're done. Okay? So sine of x plus 3 pi over 2 equals 1. Our goal right now is to start by dealing with this side. Once again, we're applying our formulas from the previous page. We're dealing with our sum and difference formulas there, right? So in this case, we have the a plus b. So that is sine of a, or x. That's right, you can't. I was hiding. There you go. Now you can. Okay. Sine of x, cosine of 3 pi over 2 plus cosine of x, sine of 3 pi over 2 equals 1. So we have 4 pieces here, 2 terms. Hi. Yeah.
Okay, so, could I switch, like, for the last part, like, for the cosine x times sine 3 pi over 2, could I switch those two?
Like, say, sine 3 pi over 2 cosine x. Does that make you feel better? Yeah, you can. Okay, you can multiply in any order. And just realize you're not going to see it like that usually in a book. And don't confuse yourself, but yeah. Okay. All right, so this is sine x. What's cos of 3 pi over 2? It's 270 degrees, which is 0. Cos x. What's sine 3 pi over 2? Negative 1. Thinking of the unit circle there. So this part becomes 0. This part is negative cos x equals 1. So that means cos x equals, right, that's negative 1 times cos x. So we divide by negative 1. So cos x equals negative 1. So the question becomes, when does cos x equal negative 1?
Oh, when it's... Oh, I know this.
What radian measure? Think of your unit circle. Good, it is pi. It's at this. That's the worst unit circle I've drawn in a long time. Okay, but it's right there. Okay, this is negative 1, right there. Cosine. It's at pi. Now, here's the problem with that answer. The answer is pi. Here's the problem with it. Cosine is a never-ending curve. It'll keep going. So it will hit it at pi. It'll hit it at 3 pi. It'll hit it at 5 pi. It'll hit it at... Okay, it'll keep hitting it every 360 degrees. Okay, so if they do not give you a restriction, which they do here, they say, solve the equation for x being between 0 and 2 pi. So, well, it only occurs once in that in that under those conditions. Okay? However, if they don't give you that, then you have to put an answer that would look something like this. Okay?
Could you do plus 2 pi n?
2 pi n. So this would have to be pi plus n times 360. But it's not asking that. So we don't have to put that.
Are you telling us this because we use it on user, or are you telling us
I'm just telling you, no, I haven't seen it in this textbook. Okay, but you will eventually get to that. Okay? It could actually be, yeah, probably since you're here, you probably could say pi plus 2 pi n. Okay, or n times 2 pi. Okay?
That seems like the right answer. Seems like that's what you're working
Okay.
for.
All right. Once again, because of this, you don't have to do that. Okay? Any questions there?
What's next?
Last problem. I saved the best one for last.
Guys, I'm so sad.
I know. I mean, we'll do more problems, but not as part of an actual set lesson.
Wait.
This is the best. All right.
Kind of x, but it's not.
Stay here. This is A, B, A, B. So if you look at this and recognize that, look, one of these took that much space, and now we have two of them,
Oh, fun.
you better write. That's why I drew my line way over here, because you're going to be, when you're going sine A times cos B minus cos A sine B. That is just for this first equation. Right? This piece is this piece. I know. Pulling out the good teaching tools for the last problem. Get the highlighter going. Okay?
I remember our first problem.
Cos x. Oops. Cos x cos pi over 2 plus sine x sine pi over 2 all equals 0. Then you go through. Hey, pi over 2 is what angle measure? 90. So when I go sine x times cosine of pi over 2, that's 0. So that whole piece is gone. Minus cos x sine pi over 2 is 1. At 90 degrees, sine is 1. Plus cos x cos pi over 2. Once again, we know this piece is going to be 0. So this part is wiped out by that 0. Plus sine x, and we know sine pi over 2 is 1. So really all that junk knocks down to negative cos x from here plus sine x. That is not the answer. That's where we're at right now.
Kendall just goes, oh.
But is everyone there? I mean, we're one step away from the answer. Okay, at this point, you go, well, there's a ton of this. But let's move this over here. Okay? If I say sine x equals cos x, right? We add cos to both sides. When does sine x equal cos x? Think of your unit circle. At what point? Yep. So we got one here is 45, root 2 over 2, root 2 over 2. That's 1. Where else? 1 pi over 4, 2 pi over 4, 3 pi. Does it work there? 3 pi over 4? No, one's positive, one's negative. 4 pi, how about? Yeah, right here. Negative root 2 over 2 and negative root 2 over 2. So our solutions are at pi over 4 and 5 pi over 4. So x is equal to pi over 4 and 5 pi over 4.
Oh my gosh, guys, we just finished our last lesson.
Oh yeah.
Awesome.
Squigglies on the list.
Yeah, we got to draw the squiggles.
Wait. Can we look at like the first one we did in this book real quick? I just want to see what it was.
You can.
Well, I don't have my first 2 pages, so I tried to duct tape them and everything.
Woohoo!